Okay, so now let's look at problems here from chapter 8, which had to do with two samples. All right, so now there were some big differences here. With two samples, you have either independent samples or dependent samples, and we treat those a little differently. And the way we set them up is slightly different, although the idea of the hypothesis test is exactly the same. So let's see. Test the claim that mu1 equals mu2, so that the population means of the two are equal. Two samples are random, independent, and come from populations that are normally distributed, and we're given the sample statistics below. Assume, so this means that the equal variances from the populations use alpha equals 0.05. Okay, in this version of the problem, what I've done is we're practicing basically setting it up and then making our decision and interpretation. And then other examples, we'll see how we can get to that P information from SPSS. All right, so we need to set up the hypothesis test, the claim that mu1 equals mu2. So that, again, has to be the null because it has the equals. And then mu1 not equal to mu2 is the alternative. And this, again, would be a two-tail. So we are given this p-value here that was obtained from all this information. So 0.347 as our p-value compared to 0.05 as our alpha, and this is definitely p is bigger than alpha, and so that is a fail to reject H0. So now we make our interpretation. What do we have here? We had the claim in the null. So that's a rejection mode. So we failed to reject it. So there is not enough evidence at the 5% significance level to reject the claim. Okay, let's look at another one here. Very similar. This time it's that mu1 is greater than mu2 with two independent samples. We have unequal population variances. Now that's not coming into play here because I'm giving the p-value. So, but we'll see that when we do the SPSS version. Okay, let's set up our hypotheses. Mu1 greater than mu2 is then our alternative, and that's our claim. And mu1 less than or equal to mu2 would be our null hypothesis. Okay. And this would be a right tail. So let's look at our p-value. Okay, 0.112 compared to our 0.01. There's your p and your alpha. Definitely p bigger than alpha. So again, we're going to fail to reject H0. Okay, but this time it's a little different because the claim is in the alternative. So that's a support mode. So we failed to reject, so we weren't able to get there. So there is not enough evidence at 1% significance level to support the claim. Okay, So now we're going to look at having data output from SPSS and see how we can interpret it to make our to get our p-value in order to make our decision and our interpretation. An engineer wants to know if producing metal bars using a new experimental treatment rather than the conventional treatment makes a difference in the tensile strength of the bars. There's our alpha. Okay, so we get, we put all the information, I'm not showing the data here, but showing the output. And we have the experimental data and the conventional data. These are independent samples. Well, they have to be, because we don't even have the same number, and plus there's no linkage between the things, between the two data sets. Okay, so what we want to do is go down here to the independent samples test information. Okay, so the first thing is I have two places, one for my equal variance is assumed and equal variance is not assumed. So remember here, you look at Levene's test. Here's the significance level from Levene's test, but this 0.01 is less than 0.05. Now, since that's small, less than our 0.05, I am not going to assume equal variances. So I'm going to instead not assume them. All right, so that means I'll be following this row here. So when I go and I want to find my significance level, I'm going to be here. Okay, but let's set it up and go back to that in a minute. Okay, because I need to know about the tails and what I'm trying to do here. So remember before we were trying to see if the new experimental treatment rather than the conventional treatment, so whether it makes a difference. So makes a difference, so the same or not the same. So making a difference would be not the same, so the mu experimental not equal to the mu conventional is really our claim here. And the mu experimental equals mu conventional would be our null because it has the equals. All right, and the equals not equals is a two-tailed. Okay, so we saw the information above and found that there's our p-value, and because we're two-tailed, we're going to use what's given. Remember, the given significance is the two-tailed version. That p-value is two-tailed. If it were one-tailed, we'd have to divide by 2. But in this case, I take that p as is, I compare it to the given alpha, it's greater than, so I fail to reject H0. That means, well, where were we? Alternative, claiming the alternative, support. So I failed to reject, though I couldn't get there. So there is not enough evidence at 5% significance level to support the claim. And to be clear, I'll say that the new treatment made a difference. Okay.